This problem, we had one like on our mid-module assessment. I think it was C. So I'm going to read it, and then you tell me what we need to draw to solve it. Jane found money in her pocket. And we don't know how much money, so I'm going to put a question mark there, okay? She went to a convenience store and spent 1/4 of her money on chocolate milk, 3/5 of her money on a magazine, and the rest of her money on candy. What fraction of her money did she spend on candy?
Depends how much money she had in the first place.
Well, no, that's what I thought to start with. But it says what fraction of her money. It doesn't say how much money. So what do I need to draw, first of all? Okay. Christian, is that what you were going to say? Whoops, that's a straight line.
I was going to skip ahead.
Okay, don't skip ahead.
You're cheating.
So, I'm also recording. Okay, so do I know my total amount on my tape diagram? Not really. But do I have a total?
Yes. No.
Well, if I pull money out of my pocket and I spend a fraction of it, what did I start with to begin with?
Money you had in your pocket.
Money in my pocket. What number would represent that if I'm going to use fractions of it? 1. So instead of a question mark here, I'm going to make that 1 whole. Okay. So now, let's see. She bought chocolate milk, she bought a magazine, and she bought candy. So how many spaces in my tape diagram? 3. What fraction of her money did she spend on chocolate milk?
1/4.
1/4. So that goes underneath. What fraction on magazines?
3/5.
3/5. And the rest on candy, and we don't know how much that was, do we? So the question mark is there. Now, in my opinion, I'm done drawing fractional models. I'm going to solve this numerically, okay? But when I have a total and I have a missing part, I'm usually going to subtract to find my missing part. But this is a 2-step problem. Step 1 is not to subtract. Jesse, what is step 1? What do you think? What do I have to figure out before I can subtract from the whole, Christian? What do I have to figure out before I can subtract from the whole?
How much in total did she waste on?
How much she already used, right? Okay, so I'm going to add these two together, the magazine and the chocolate milk. But I'm going to do it numerically. That's step 1. Step 2 is subtract from the whole. Most of you on your test forgot step 2. Okay? All right. So the first thing I want to do is rewrite the problem. So 1/4 plus 3/5. And then we'll solve this numerically. So when I do this, and I've shown you this before, the way we solve these, we'll start out with something that looks like that, parentheses. And we're going to find common denominators without the area models. And when I copy this down, I want to give you a visual so that maybe you can go back and, if it works. These two are just basically getting moved over and to be the first number in the problem. So that my 1/4 goes here and my 3/5 goes here. And when I was using my iPad this morning, I could drag them each individually, but this board doesn't work as easily as the iPad. Okay, so now I'm ready for my common denominator. Emily, what is it? Nothing has changed. Do we still look at those two, and what are we going to do to them? Multiply them together. Okay, so we've got 20. And then this is pretty hard. I don't know if you can follow this or not. But 4 times what equals 20? Hint, it's right there. 5. So that means 1 times 5 is the answer to my first numerator. And then looking in the next set of parentheses, 5 times something equals 20. Miley, what is it? Hint, it's right there. Okay. So now 3 times 4 is what?
12.
And that's my second numerator. Now I can simply add it together. Daniel, what do I get for my answer? 17 20ths. So now I know that 17 20ths, no, I don't.
Actually, you do know how much candy.
No. I know how much chocolate milk and magazines were together. Now how do I figure out what candy is? Daniel?
320.
Okay, but what'd you do? What problem did you do to figure that out? 20 20ths. Now where'd you get that?
By 1 whole.
1 whole. 1 whole is actually 20 20ths, isn't it? Okay. And the reason we couldn't fill that in yet is because we didn't have a denominator. Okay, so then he says 3 20ths is the answer to what fraction of her money she spent on candy. You agree?
Yes.
Okay, so now I'm going to make it a little harder, okay? Let's say the 1 whole was actually $10. Ooh, okay. So let's solve this. We'll need another tape diagram. Guess what my total is this time?
$10.
$10. And I'm going to raise this up. Okay. So we said, I don't really like that. Oh, that's funny. We said we had 20 equal parts, correct?
Yes.
So how many equal parts will I need on my tape diagram?
20.
20, because $10 is my total. Now I'm going to go ahead and do it this way because I don't really want to do 20 equal parts. Are you okay with that?
Yes.
This is where we skip all the parts in the middle, but we know there are 20.
Yeah, make 20.
So how do I, and shaded, don't do this, I'm just going to do it as a visual. Shaded, this is the amount that she spent on candy, correct? But don't do that part, don't shade it because we're going to need to write in there. Okay, so how do I solve a problem like this where I know the total and I know the number of boxes? Multiply or divide?
Divide.
Awesome. When I divide $10 by 20, something happens here. Right away I notice. What do I notice, Christian?
It's going to be a decimal.
I'm going to have to use a decimal. Which makes sense because how do I go ahead and write $10 anyway? Decimal, 0, 0. So it makes sense. Just go ahead and write $10 and leave the decimal there because you're going to have to show hundredths place anyway because it's money. Okay? So now I'm thinking what? Chunk it at 100? Okay, how many groups of 20 can I make out of 100? 5. And it goes above the second 0. And I get 0, bring down 0. And what do I fill in with at the top? 0. So, speaking of money, how much money is that?
50 cents.
50 cents. So if I put 50 cents in each of these boxes, I'll know how many 3 of them would be. Be more specific. We're talking money.
$50 and 2 quarters.
$1 2 quarters, $1.50. Okay. Someone in block 2 said 150, and I said, you know what? You're not wrong. It's 150 cents. Okay. As long as you know where to put your decimal and you know how to write your dollar sign, you're good. Okay. That was a hard problem. I think you could actually do that on your own. Okay. So let's take a look at today's lesson. Now notice that your shading doesn't really look very good. So I'm fine if you just want to shade these where they were shaded on mine. Now the lesson today is not just adding numbers. If we were adding these mixed numbers and whole numbers, we could do it in our head. Subtracting is a little bit harder, but I still think we could do it in our head. Okay? The lesson today is to model this addition problem on a number line. So before we ever start, I want to think in terms of tape diagrams. Okay? So if one fully shaded bar represents one whole, what addition problem would match this drawing? Well, this is one whole, right?
0 plus 1.
And then a plus sign. Then what?
1, 1.
Another one whole. And
3/4.
3/4. So we will model this problem on a number line. Now there are several steps we will go through. They're going to seem very simple. I know you already know the answer, okay? That's not why we're doing this. We're not doing this to find the answer. So the best thing to do when you come across a problem like this is to separate everything out. So if I were to separate everything out, I'd add another plus sign. Where would I add it? Did you see where I put it?
Yeah.
Okay, between these two. And then, I know we don't have enough room to rewrite at the top, so let's just rewrite underneath it, okay? So I'm going to rewrite this problem as 1 plus 1 plus 3/4. And you'll see why. And then I'm going to scroll down on this so that you can see what I'm going to do. Now, there are a few things that are going to happen every single time we do this on a number line, okay? Addition is different than subtraction on a number line because of the direction you're moving, okay? When it's addition, you're moving to the right where numbers get larger. When you're subtracting, your numbers are getting smaller, so you're moving to the left, okay? So when I'm doing addition, I'm going to always start with 0, and I'm always going to move to the right, okay? So and then there's another thing we're skipping. We're not putting everything on this number line. And I got that idea from Dwayne because you don't really need to. I just thought, oh gosh, I've got to figure out what this number is at the end, and then I got to figure out all my whole numbers, and then I've got to put all my tick marks for my fractions. And Dwayne's not a woman, is he? And he doesn't think the same way I do, and he's like, why would I need all that stuff? Okay? So I'm just going to show the first whole number. What is it?
1.
So I'm going to add 1. So everyone just do what I do. Now when I add 1 to 0, what whole number does that put me at?
1.
1. Now what's my second number say to do?
1.
So I'm going to add 1. What whole number, Miley, am I at now? 2. So on my problem, I'm going to do 2 plus 3/4. And that's the reason for the 3 equal signs. Okay, so what's the final number on my number line?
2 3/4.
No, I'm talking whole numbers.
Oh, 3.
3, okay? And I'm going to keep these kind of even. So my 3 goes, kind of about the same. Did you see me do a bunny hop yet?
No.
Okay, so don't do that yet. Just mark your last whole number. Before I can do bunny hops, I have to divide it into, what's my denominator?
3/4.
Fourths. So that means 3 tick marks. And this is where I would have said, okay, I've got to mark all of these down. And the answer is no, you don't have to. So what am I adding?
3/4.
Watch me. 1, 2, 3. And then you just write the answer. Now, the answer isn't 3/4. What's the answer? 2 3/4. So I've got to put a 2 in front of it, and then I want you to circle it. Okay, now this is adding on the number line. We're going to do one more addition, then we'll practice some subtraction, okay? And pretty much the same thing's going to happen. We're going to start with 0, we'll move to the right when we're adding. Okay, here's the problem. And make sure you're on problem 2, and this is not part of the actual addition problem, okay? So don't mistake that 2 for part of it. I really think I should have moved those words maybe up above it or something. That would have made more sense. How did I put it on yours? The same way? Okay. So on this one, before I ever start, I'm going to rewrite this problem. Now, Yosin, tell me why you think I want to rewrite this addition problem.
Because it's gonna, you're gonna have to put it
What do I want to add at the very end, probably?
all of them.
Like, what's the last thing I want on my number line? The whole numbers or the fraction?
Fraction.
The fraction. So I want to rearrange this so the fraction's at the end. Okay? So in order to do that, I'm going to move my whole numbers. 2 plus 3 plus 3/10. Now, by the way, someone in block 1 said, well, the answer's 5 3/10. I said, I know that, but that's not what we're doing. We're showing this problem on a number line. Now, do you remember what property of addition tells us? That we can move these numbers around and it will not affect our answer? What property is that? Commutative property. Here's what it says. The order of the add-ins or the factors does not affect the sum or the product. So we use it in multiplication and addition. And I could put the 3 in front if I wanted to, but I'm trying to keep these in the order of the problem, okay? So, what's the first number I'm adding?
2.
Plus 2. Are you done?
Yeah.
Okay, what do you want to do? Hold on, let me pause this.
PE was like.
Okay, so what am I adding? Oh, by the way, what whole number does adding 2 to 0 bring me to? Okay, so you're with me? What am I adding next?
3.
So I'm going to go a little further and I'm going to add 3 this time. Notice I didn't write anything at the bottom yet. Okay, if I add 3 to the whole number of 2, what does that take me to?
5.
Okay, so that's my next row. 5 plus 3/10. Miley, did you write 5 plus 3/10 down here? Okay, so the final whole number I need is what?
3/10.
Whole number.
Oh, 6.
6. And I'm just going to put it over here and give myself enough room. The reason I know 6 is the highest I need to go is because 3/10 is less than 1 whole. So what's my denominator, Lapita?
10.
Okay, so that means I need 9 tick marks. I'm going to do 2 groups of 5. That's easier for me. Okay, so what am I adding to 5? 3/10. So watch my pen. 1, 2, 3, plus 3/10. So my answer is what, boys and girls? 5 3/10. I have to label this very last tick mark as 3/10. And since the 5 is so close to it, I would just probably do it like that. Just circle it off. Okay, Tobias, what's your question? 5 3/10. What is, oh yeah, it is. 5 3/5 is 53/5. You're thinking of decimal place value. My goodness. How impressive. Okay, so this is going to change a little bit with subtraction. Look at the next problem. It's subtraction. Okay, problem 3 shows subtraction. Subtraction's different because it starts on the right and moves towards
The left.
So I'm going to start on the right side of my number line. This is something you'll do every time when you're subtracting. And I'm going to write down the very first number of my problem. What is it? 1. So 1 goes here. And then what whole number comes after 1?
2.
Well, when I'm subtracting, 0. Okay, so I should say comes before 1, shouldn't I? And in 5th grade, we don't work with negative numbers, so you can know that 0 is going to be where you stop. Okay? All right. But if I started at like 19, I don't think I would go all the way to 0, would I? Not unless I was going to subtract 18 plus a fraction. Okay? So I need you to listen, not have side conversations. So what am I subtracting? 1/4. So denominator is 4. So I'm going to break it into 4 equal parts. That would be 3 tick marks. And I'm only going to break apart between whole numbers, okay? Just so happens this one is our whole number line. So I'll subtract 1/4. Now there are a couple ways to think about the answer. I'm trying to think who it was. I think it might have been Alice. She said, well, I'm just going to think about what makes 1 whole. 4/4 makes 1 whole. So in her mind, she's going to do 4/4 minus 1/4. 3/4, okay? I kind of do this. I kind of look at the 4 and look at the 1, do a little subtraction problem. What's 4 minus 1? So that's how I know where I'm ending up. Blair, and I don't want you to write this, but Blair said, well, I just think about what I'm going to add to it to make 1 whole. He said, I'm just going to start at 1. I'm going to go 1, 2, 3. That's how I know that's my answer. Okay? There's no one right way to do this. All I want you to make sure you do is notice that the fractions are different now. And if you accidentally write 1/4 for your answer, you did something wrong. Because you've got to come up with an answer that's different when you're subtracting. So my answer is 3/4 and circle it. Would I write a 0 in front of it for any reason? No. Okay, let's do the next one.
That was easy.
Yeah. Okay, so in subtraction, you'll start on the right and you'll start with the first number of your problem. So what's the end mark on the right?
2.
Okay.
Would that one be
This is where you have to decide based on your denominator, okay? So if I'm subtracting less than 1 whole, I know I'm going to need a 1, but I'm going to put a 0 because that's my personal preference, okay? I like to see the whole picture if I can. Now, if I started, like I said, with 19, I probably wouldn't put the 0 on it. I'd just go as far as I had to, okay? All right, so if I start at 2 and I subtract 3/5, what do I have to partition this number line into? 5 equal parts. So 5ths would be how many tick marks? 4. 4 tick marks. So get that done now. And if I subtract 3/5, watch my pen. I'll do it like this. 1, 2, 3. Minus 3/5. Okay? So 2 minus 3/5. Now there's more than one way to think of it. You can think of, okay, this would be 5/5 for a whole. So 5/5 minus 3 is 2. You can think of it like I do and do a little subtraction problem in your head. 5 minus 3 equals 2, and then I know what my denominator is, okay? Or you could think, okay, that would be 1, 2, and count forward. It's your choice. So my answer is what, boys and girls? 1 2/5. Is that what you were going to tell me, Jose? Don't forget your 1 whole. 1 2/5. Okay, let's do another. All right, this says 3 minus 1 2/3. I want to rewrite this problem. Why do I want to rewrite it?
Because there's 2 whole numbers.
There's 2 whole numbers. And I want to separate things out, and there's a chance I might have to rearrange it. And I just want to make sure that I've done everything I can to make myself successful. So, do you remember on the first problem we did with the tape diagrams, I stuck a little plus sign between?
Yeah.
Well, I'm going to stick a little subtraction sign in there. So, 3 minus 1 minus
1/2.
2/3. 2/3. Okay. So the subtraction problem starts on the right.
Yeah.
What number will I start with?
3.
I always start with my first number of the problem. So I'll start with the 3. And I don't know what I'm going to have on there next, but I'm going to look at my problem. So Jose, what do I need to subtract first? Minus 1. So just subtract 1, minus 1. Miley, what whole number does that take me to if I subtract 1? 2. Make sure you put a tick mark for the whole number. And I'm going to go ahead and write this whole number because I really need it. Otherwise, I can't partition. So now down here at the bottom, Michael, stop. 2 minus 2/3. Okay? So what will I partition these between these 2 whole numbers?
3.
3's. And I'm going to do 2 tick marks to make 3 equal parts. I'm going to go ahead and put the 0 on there just so I have something at the end. But you don't need it, do you?
No.
Okay. So now I'm going to subtract 2/3. Watch me. 1, 2. Did you notice I didn't hop all the way there?
Yes.
That's because those are fractions, and we're showing fractional parts of a whole. That's the reason for the little bunny hops. Okay, and then in my mind, I'm going to do 3 minus 2.
1/3.
And I can probably circle it like that, can't I? So the answer is,
1 1/3.
what?
1 1/3.
1 1/3, and what did I write?
1 2/3.
Okay.